Piaget's theory of cognitive development.
Piaget's theory of cognitive development is a comprehensive theory about the nature and development of human intelligence, first developed by Swiss developmental psychologist Jean Piaget. It is primarily known as a developmental stage theory but, in fact, it deals with the nature of knowledge itself and how humans come gradually to acquire, construct, and use it. To Piaget, cognitive development was a progressive reorganization of mental processes as a result of biological maturation and environmental experience. Accordingly, children construct an understanding of the world around them, then experience discrepancies between what they already know and what they discover in their environment. Moreover, Piaget claimed the idea that cognitive development is at the center of human organism, and language is contingent on cognitive development. Below is a short description of Piaget's views about the nature of intelligence, followed by a description of the stages through which it develops until maturity.
Nature of intelligence, operative and figurative.
Piaget noted reality in the sense of as a dynamic system of continuous change and, as such, is defined in reference to the two conditions that define dynamic systems. Specifically, he argued that reality involves transformations and states. Transformations refer to all manners of changes that a thing or person can undergo. States refer to the conditions or the appearances in which things or persons can be found between transformations. For example, there might be changes in shape or form. For instance, liquids are reshaped as they are transferred from one vessel to another. Humans change in their characteristics as they grow older, in size. For example, a series of coins on a table might be placed close to each other or far apart, or in placement or location in space and time. For example, various objects or persons might be found at one place at one time and at a different place at another time. Thus, Piaget argued, if human intelligence is to be adaptive, it must have functions to represent both the transformational and the static aspects of reality. He proposed that operative intelligence is responsible for the representation and manipulation of the dynamic or transformational aspects of reality, and that figurative intelligence is responsible for the representation of the static aspects of reality. Operative intelligence is the active aspect of intelligence. It involves all actions, overt or covert, undertaken in order to follow, recover, or anticipate the transformations of the objects or persons of interest. Figurative intelligence is the more or less static aspect of intelligence, involving all means of representation used to retain in mind the states, that is, successive forms, shapes, or locations, that intervene between transformations. That is, it involves perception, imitation, mental imagery, drawing, and language. Therefore, the figurative aspects of intelligence derive their meaning from the operative aspects of intelligence, because states cannot exist independently of the transformations that interconnect them. Piaget stated that the figurative or the representational aspects of intelligence are subservient to its operative and dynamic aspects, and therefore, that understanding essentially derives from the operative aspect of intelligence. At any time, operative intelligence frames how the world is understood and it changes if understanding is not successful. Piaget stated that this process of understanding and change involves two basic functions, assimilation and accommodation.
Assimilation and accommodation.
Through his study of the field of education, Piaget focused on two processes, which he named assimilation and accommodation. Assimilation describes how humans perceive and adapt to new information. It is the process of fitting new information into pre-existing cognitive schemas. Assimilation occurs when humans are faced with new or unfamiliar information and refer to previously learned information in order to make sense of it. Unlike it, accommodation is the process of taking new information in one's environment and altering pre-existing schemas in order to fit in the new information. Through a series of stages, Piaget explains the ways in which characteristics are constructed that lead to specific types of thinking. This chart is called cognitive development. To Piaget, assimilation is integrating external elements into structures of lives or environments, or those we could have through experience. It is through assimilation that accommodation is derived. Accommodation is imperative because it is how people will continue to interpret new concepts, schemas, frameworks, and more. Assimilation is different from accommodation by how it relates to the inner organism due to the environment. Piaget believes that the human brain has been programmed through evolution to bring equilibrium, which is what Piaget believes ultimately influences structures by the internal and external processes through assimilation and accommodation. Piaget's understanding is that these two functions cannot exist without the other. To assimilate an object into an existing mental schema, one first needs to take into account or accommodate to the particularities of this object to a certain extent. For instance, to recognize, assimilate, an apple as an apple, one must first focus, accommodate, on the contour of this object. To do this, one needs to roughly recognize the size of the object. Development increases the balance, or equilibration, between these two functions. When in balance with each other, assimilation and accommodation generate mental schemas of the operative intelligence. When one function dominates over the other, they generate representations which belong to figurative intelligence.
Sensorimotor stage.
The sensorimotor stage is the first of the 4 stages in cognitive development which extends from birth to the acquisition of language. In this stage, infants progressively construct knowledge and understanding of the world by coordinating experiences, such as vision and hearing, with physical interactions with objects, such as grasping, sucking, and stepping. Infants gain knowledge of the world from these physical actions they perform within it. They progress from reflexive, instinctual action at birth to the beginning of symbolic thought toward the end of the stage. The child learns that he/she is separate from the environment and that aspects of the environment continue to exist, even though they may be outside the reach of the child's senses. In this stage, according to Piaget, the development of object permanence is one of the most important accomplishments. Object permanence is a child's understanding that objects continue to exist even though they cannot be seen or heard. Piaget divided the sensorimotor stage into 6 substages. By the end of the sensorimotor period, the child sees objects as both separate from the self, and permanent.
Pre-operational stage.
Piaget's second stage, the pre-operational stage, starts when the child begins to learn to speak at age 2 and lasts up until the age of 7. During the pre-operational stage of cognitive development, Piaget noted that children do not yet understand concrete logic and cannot mentally manipulate information. Children's increase in playing and pretending takes place in this stage. However, the child still has trouble seeing things from different points of view. The children's play is mainly categorized by symbolic play and manipulating symbols. Such play is demonstrated by the idea of checkers being snacks, pieces of paper being plates, and a box being a table. Their observations of symbols exemplifies the idea of play with the absence of the actual objects involved. By observing sequences of play, Piaget was able to demonstrate that, towards the end of the second year, a qualitatively new kind of psychological functioning occurs, known as the pre-operational stage. The pre-operational stage is sparse and logically inadequate in regard to mental operations. The child is able to form stable concepts as well as magical beliefs. The child, however, is still not able to perform operations, which are tasks that the child can do mentally, rather than physically. Thinking in this stage is still egocentric, meaning the child has difficulty seeing the viewpoint of others. The pre-operational stage is split into 2 substages, the symbolic function substage, and the intuitive thought substage. The symbolic function substage is when children are able to understand, represent, remember, and picture objects in their mind without having the object in front of them. The intuitive thought substage is when children tend to propose the questions of, why? And, how come? This stage is when children want the knowledge of knowing everything.
Symbolic function substage.
At about 2 to 4 years of age, children cannot yet manipulate and transform information in a logical way. However, they now can think in images and symbols. Other examples of mental abilities are language and pretend play. Symbolic play is when children develop imaginary friends or role play with friends. Children's play becomes more social and they assign roles to each other. Some examples of symbolic play include playing house, or having a tea party. Interestingly, the type of symbolic play in which children engage is connected with their level of creativity and ability to connect with others. Additionally, the quality of their symbolic play can have consequences on their later development. For example, young children whose symbolic play is of a violent nature tend to exhibit less prosocial behavior and are more likely to display antisocial tendencies in later years. In this stage, there are still limitations, such as egocentrism and precausal thinking. Egocentrism occurs when a child is unable to distinguish between their own perspective and that of another person. Children tend to stick to their own viewpoint, rather than consider the view of others. Indeed, they are not even aware that such a concept as different viewpoints exists. Egocentrism can be seen in an experiment performed by Piaget and Swiss developmental psychologist Barbel and Helder, known as the three-mountain problem. In this experiment, three views of a mountain are shown to the child, who is asked what a traveling doll would see at the various angles. The child will consistently describe what they can see from the position from which they are seated, regardless of from what angle they are asked to take the doll's perspective. Egocentrism would also cause a child to believe, "I like Sesame Street, so Daddy must like Sesame Street too." Similar to preoperational children's egocentric thinking is their structuring of a cause-and-effect relationships. Piaget coined the term precausal thinking to describe the way in which preoperational children use their own existing ideas or views, like in egocentrism, to explain cause-and-effect relationships. Three main concepts of causality as displayed by children in the preoperational stage include animism, artificialism and transductive reasoning. Animism is the belief that inanimate objects are capable of actions and have lifelike qualities. An example could be a child believing that the sidewalk was mad and made them fall down, or that the stars twinkle in the sky because they are happy. Artificialism refers to the belief that environmental characteristics can be attributed to human actions or interventions. For example, a child might say that it is windy outside because someone is blowing very hard, or the clouds are white because someone painted them that color. Finally, precausal thinking is categorized by transductive reasoning. Transductive reasoning is when a child fails to understand the true relationships between cause and effect. Unlike deductive or inductive reasoning, general to specific, or specific to general, transductive reasoning refers to when a child reasons from specific to specific, drawing a relationship between two separate events that are otherwise unrelated. For example, if a child hears the dog bark and then a balloon popped, the child would conclude that because the dog barked, the balloon popped.
Intuitive thought substage.
At between about the ages of 4 and 7, children tend to become very curious and ask many questions, beginning the use of primitive reasoning. There is an emergence in the interest of reasoning and wanting to know why things are the way they are. Piaget called it the intuitive substage, because children realize they have a vast amount of knowledge, but they are unaware of how they acquired it. Centration, conservation, irreversibility, class inclusion, and transitive inference are all characteristics of preoperative thought. Centration is the act of focusing all attention on one characteristic or dimension of a situation, whilst disregarding all others. Conservation is the awareness that altering a substance's appearance does not change its basic properties. Children at this stage are unaware of conservation and exhibit centration. Both centration and conservation can be more easily understood once familiarized with Piaget's most famous experimental task. In this task, a child is presented with two identical beakers containing the same amount of liquid. The child usually notes that the beakers do contain the same amount of liquid. When one of the beakers is poured into a taller and thinner container, children who are younger than 7 or 8 years old typically say that the two beakers no longer contain the same amount of liquid, and that the taller container holds the larger quantity, centration, without taking into consideration the fact that both beakers were previously noted to contain the same amount of liquid. Due to superficial changes, The child was unable to comprehend that the properties of the substances continued to remain the same. Conservation. Irreversibility is a concept developed in this stage which is closely related to the ideas of centration and conservation. Irreversibility refers to when children are unable to mentally reverse a sequence of events. In the same beaker situation, the child does not realize that, if the sequence of events was reversed and the water from the tall beaker was poured back into its original beaker, then the same amount of water would exist. Another example of children's reliance on visual representations is their misunderstanding of less than, or more than. When two rows containing equal amounts of blocks are placed in front of a child, one row spread farther apart than the other, the child will think that the row spread farther contains more blocks. Class inclusion refers to a kind of conceptual thinking that children in the pre-operational stage cannot yet grasp. Children's inability to focus on two aspects of a situation at once inhibits them from understanding the principle that one category or class can contain several different subcategories or classes. For example, a 4-year-old girl may be shown a picture of 8 dogs and 3 cats. The girl knows what cats and dogs are, and she is aware that they are both animals. However, when asked, "Are there more dogs or animals?" she is likely to answer more dogs. This is due to her difficulty focusing on the two subclasses and the larger class all at the same time. She may have been able to view the dogs as dogs or animals, but struggled when trying to classify them as both, simultaneously. Similar to this is concept relating to intuitive thought, known as transitive inference. Transitive inference is using previous knowledge to determine the missing piece, using basic logic. Children in the pre-operational stage lack this logic. An example of transitive inference would be when a child is presented with the information A is greater than B, and B is greater than C. This child may have difficulty here understanding that A is also greater than C.
Concrete operational stage.
The concrete operational stage is the third of 4 stages from Piaget's theory of cognitive development. This stage, which follows the pre-operational stage, occurs between the ages of 7 and 11 years, and is characterized by the appropriate use of logic. During this stage, a child's thought processes become more mature and adult-like. They start solving problems in a more logical fashion. Abstract, hypothetical thinking has not yet developed, and children can only solve problems that apply to concrete events or objects. Piaget determined that children are able to incorporate inductive reasoning. Inductive reasoning involves drawing inferences from observations in order to make a generalization. In contrast, children struggle with deductive reasoning, which involves using a generalized principle in order to try to predict the outcome of an event. Children in this stage commonly experience difficulties with figuring out logic in their heads. For example, a child will understand that A is more than B, and B is more than C. However, when asked is A more than C, the child might not be able to logically figure the question out in their heads.
Milestones of the concrete operational stage.
The primary milestones of a child's concrete operational stage are: ability to distinguish between their own thoughts and the thoughts of others. Children recognize that their thoughts and perceptions may be different from those around them. Increased classification skills. Children are able to classify objects by their number, mass, and weight. Ability to think logically about objects and events. Ability to fluently perform mathematical problems in both addition and subtraction.
Important processes.
Important processes during the concrete operational stage include: classification, the ability to name and identify sets of objects according to appearance, size or other characteristic, including the idea that one set of objects can include another. Hierarchical classification refers to the ability to sort objects into classes and subclasses based on similarities and differences among groups. Conservation, the understanding that, although an object's appearance changes, it still stays the same in quantity. Redistributing an object does not affect its mass, number, or volume. For example, a child understands that when you pour a liquid into a different shaped glass, the amount of liquid stays the same. Decentering, the child now takes into account multiple aspects of a problem to solve it. For example, the child will no longer perceive an exceptionally wide but short cup to contain less than a normally wide, taller cup. Reversibility, the child now understands that numbers or objects can be changed and then returned to their original state. For example, a child understands that his or her favorite ball that deflates is not gone and can be filled with air and put back into play again. Another example would be when the child realizes that a ball of clay, once flattened, can be made into a ball of clay again. Seriation, the ability to sort objects in an order according to size, shape, or any other characteristic. For example, different shaded objects may make a color gradient. Transitivity, which refers to the ability to mentally sort objects and recognize relationships among various things in a serial order. For example, when told to put away his books according to height, the child recognizes that he starts with placing the tallest one on one end of the bookshelf and the shortest at the other end. Two other important processes in the concrete operational stage are the elimination of egocentrism and logic. Egocentrism is the inability to consider or understand a perspective other than one's own. During this stage, the child acquires the ability to view things from another individual's perspective, even if they think that perspective is incorrect. For instance, show a child a comic in which Jane puts a doll under a box, leaves the room, and then Melissa moves the doll to a drawer, and Jane comes back. A child in the concrete operations stage will say that Jane will still think it's under the box even though the child knows it is in the drawer. See also false belief task. Children in this stage can, however, only solve problems that apply to actual, concrete, objects or events, and not abstract concepts or hypothetical tasks. Understanding and knowing how to use full common sense has not yet been completely adapted. Piaget determined that children in the concrete operational stage were able to incorporate inductive logic. On the other hand, children at this age have difficulty using deductive logic, which involves using a general principle to predict the outcome of a specific event. This includes mental reversibility. An example of this is being able to reverse the order of relationships between mental categories. For example, a child might be able to recognize that his or her dog is a Labrador, that a Labrador is a dog, and that a dog is an animal, and draw conclusions from the information available, as well as apply all these processes to hypothetical situations. The abstract quality of the adolescent's thought at the formal operational level is evident in the adolescent's verbal problem-solving ability. The logical quality of the adolescent's thought is when children are more likely to solve problems in a trial-and-error fashion. Adolescents begin to think more as a scientist thinks, devising plans to solve problems and systematically test opinions. They use hypothetical deductive reasoning, which means that they develop hypotheses or best guesses, and systematically deduce, or conclude, which is the best path to follow in solving the problem. During this stage the adolescent is able to understand such things as love, shades of grey, logical proofs and values. During this stage the young person begins to entertain possibilities for the future and is fascinated with what they can be. Adolescents also are changing cognitively by the way that they think about social matters. Adolescent egocentrism governs the way that adolescents think about social matters, and is the heightened self-consciousness in them as they are, which is reflected in their sense of personal uniqueness and invincibility. Adolescent egocentrism can be dissected into two types of social thinking: imaginary audience that involves attention-getting behavior, and personal fable, which involves an adolescent's sense of personal uniqueness and invincibility. These two types of social thinking begin to affect a child's egocentrism in the concrete stage. However, it carries over to the formal operational stage when they are then faced with abstract thought and fully logical thinking.
Testing for concrete operations.
Piagetian tests are well known and practiced to test for concrete operations. The most prevalent tests are those for conservation. There are some important aspects that the experimenter must take into account when performing experiments with these children. One example of an experiment for testing conservation is an experimenter will have two glasses that are the same size, fill them to the same level with liquid, which the child will acknowledge is the same. Then, the experimenter will pour the liquid from one of the small glasses into a tall, thin glass. The experimenter will then ask the child if the taller glass has more liquid, less liquid, or the same amount of liquid. The child will then give his answer. The experimenter will ask the child why he gave his answer, or why he thinks that is. Justification: after the child has answered the question being posed, the experimenter must ask why the child gave that answer. This is important because the answers they give can help the experimenter to assess the child's developmental age. Number of times asking: some argue that if a child is asked if the amount of liquid in the first set of glasses is equal, then, after pouring the water into the taller glass, the experimenter asks again about the amount of liquid, the children will start to doubt their original answer. They may start to think that the original levels were not equal, which will influence their second answer. Word choice: the phrasing that the experimenter uses may affect how the child answers. If, in the liquid and glass example, the experimenter asks, which of these glasses has more liquid? The child may think that his thoughts of them being the same is wrong because the adult is saying that one must have more. Alternatively, if the experimenter asks, are these equal? Then the child is more likely to say that they are, because the experimenter is implying that they are.
Formal operational stage.
The final stage is known as the formal operational stage, adolescence and into adulthood, roughly ages 11 to approximately 15 to 20. Intelligence is demonstrated through the logical use of symbols related to abstract concepts. At this point, the person is capable of hypothetical and deductive reasoning. During this time, people develop the ability to think about abstract concepts. Piaget stated that hypothetico-deductive reasoning becomes important during the formal operational stage. This type of thinking involves hypothetical situations and is often required in science and mathematics. Abstract thought emerges during the formal operational stage. Children tend to think very concretely and specifically in earlier stages, and begin to consider possible outcomes and consequences of actions. Metacognition, the capacity for thinking about thinking that allows adolescents and adults to reason about their thought processes and monitor them. Problem solving is demonstrated when children use trial and error to solve problems. The ability to systematically solve a problem in a logical and methodical way emerges. However, research has shown that not all persons in all cultures reach formal operations, and most people do not use formal operations in all aspects of their lives.
The stages in causation.
Piaget sees children's conception of causation as a march from primitive conceptions of cause to those of a more scientific, rigorous, and mechanical nature. These primitive concepts are characterized as supernatural, with a decidedly non-natural or non-mechanical tone. Piaget has as his most basic assumption that babies are phenomenists. That is, their knowledge consists of assimilating things to schemas from their own actions such that they appear, from the child's point of view, to have qualities which, in fact, stem from the organism. Consequently, these subjective conceptions, so prevalent during Piaget's first stage of development, are dashed upon discovering deeper empirical truths. Piaget gives the example of a child believing that the moon and stars follow him on a night walk. Upon learning that such is the case for his friends, he must separate himself from the object, resulting in a theory that the moon is immobile, or moves independently of other agents. The second stage, from around 3 to 8 years of age, is characterized by a mix of this type of magical, animistic, or non-natural conceptions of causation and mechanical or naturalistic causation. This conjunction of natural and non-natural causal explanations supposedly stems from experience itself, though Piaget does not make much of an attempt to describe the nature of the differences in conception. In his interviews with children, he asked questions specifically about natural phenomena, such as, what makes clouds move? What makes the stars move? Why do rivers flow? The nature of all the answers given, Piaget says, are such that these objects must perform their actions to fulfill their obligations towards men. He calls this moral explanation.
Practical applications.
parents can use Piaget's theory when deciding how to determine what to buy in order to support their child's growth. Teachers can also use Piaget's theory, for instance, when discussing whether the syllabus subjects are suitable for the level of students or not. For example, recent studies have shown that children in the same grade and of the same age perform differentially on tasks measuring basic addition and subtraction fluency. While children in the pre-operational and concrete operational levels of cognitive development perform combined arithmetic operations, such as addition and subtraction, with similar accuracy, children in the concrete operational level of cognitive development have been able to perform both addition problems and subtraction problems with overall greater fluency. The ability to perform mathematical operations fluently indicates a level of skill mastery and a readiness to learn more advanced mathematical problems. Teachers who work with children in both the pre-operational and the concrete operational levels of cognitive development should adopt suitable academic expectations with regard to children's cognitive developmental abilities. The need for educators to individualize and adopt appropriate academic expectations appears to be most relevant for children at the first grade level.
Postulated physical mechanisms underlying schemes and stages.
In 1967, Piaget considered the possibility of RNA molecules as likely embodiments of his still abstract schemes, which he promoted as units of action, though he did not come to any firm conclusion. At that time, due to work such as that of Swedish biochemist Holger Heiden, RNA concentrations had, indeed, been shown to correlate with learning, so the idea was quite plausible. However, by the time of Piaget's death in 1980, this notion had lost favor. One main problem was over the protein which, it was assumed, such RNA would necessarily produce, and that did not fit in with observation. It was determined that only about 3% of RNA does code for protein, Mitic, 2001, 2003, 2004. Hence, most of the remaining 97%, the ncRNA could theoretically be available to serve as Piagetian schemes, or other regulatory roles now under investigation. The issue has not yet been resolved experimentally, but its theoretical aspects were reviewed in 2008. Then developed further from the viewpoints of biophysics and epistemology. Meanwhile, this RNA-based approach also unexpectedly offered explanations for various other biomysteries, thus providing some measure of corroboration.
Relation to psychometric theories of intelligence.
Piaget designed a number of tasks to verify hypotheses arising from his theory. The tasks were not intended to measure individual differences, and they have no equivalent in psychometric intelligence tests. Notwithstanding the different research traditions in which psychometric tests and Piagetian tasks were developed, the correlations between the two types of measures have been found to be consistently positive and generally moderate in magnitude. A common general factor underlies them. It has been shown that it is possible to construct a battery consisting of Piagetian tasks that is as good a measure of general intelligence as standard IQ tests.
Challenges to Piagetian stage theory.
Piagetian's accounts of development have been challenged on several grounds. First, as Piaget himself noted, development does not always progress in the smooth manner his theory seems to predict. Decalage, or unpredicted gaps in the developmental progression, suggest that the stage model is, at best, a useful approximation. Furthermore, studies have found that children may be able to learn concepts supposedly represented in more advanced stages with relative ease. More broadly, Piaget's theory is domain general, predicting that cognitive maturation occurs concurrently across different domains of knowledge, such as mathematics, logic, and understanding of physics or language. During the 1980s and 1990s, cognitive developmentalists were influenced by neo-nativist and evolutionary psychology ideas. These ideas de-emphasized domain general theories and emphasized domain specificity or modularity of mind. Modularity implies that different cognitive faculties may be largely independent of one another, and thus develop according to quite different timetables. In this vein, some cognitive developmentalists argued that, rather than being domain general learners, children come equipped with domain-specific theories, sometimes referred to as core knowledge, which allows them to break into learning within that domain. For example, even young infants appear to be sensitive to some predictable regularities in the movement and interactions of objects, for example, that one object cannot pass through another, or in human behavior, for example, that a hand repeatedly reaching for an object has that object, not just a particular path of motion, as it becomes the building block of which more elaborate knowledge is constructed. More recent work has strongly challenged some of the basic presumptions of the core knowledge school, and revised ideas of domain generality, but from a newer dynamic systems approach, not from a revised Piagetian perspective. Dynamic systems approaches hearken to modern neuroscientific research that was not available to Piaget when he was constructing his theory. One important finding is that domain-specific knowledge is constructed as children develop and integrate knowledge. This suggests more of a smooth integration of learning in development than either Piaget, or his neo-nativist critics, had envisioned. Additionally, some psychologists, such as Lev Vygotsky and Jerome Bruner, thought differently from Piaget, suggesting that language was more important than Piaget implied.
Post-Piagetian and Neo-Piagetian stages.
In recent years, several scholars attempted to address concerns with Piaget's theory by developing new theories and models that can accommodate evidence which violates Piagetian predictions and postulates. The Neo-Piagetian theories of cognitive development, advanced by Case, Demetria, Harford, Fisher, Michael Commons, and Pasquale Leone, attempted to integrate Piaget's theory with cognitive and differential theories of cognitive organization and development. Their aim was to better account for the cognitive factors of development and for intra-individual and inter-individual differences in cognitive development. They suggested that development along Piaget's stages is due to increasing working memory capacity and processing efficiency. Moreover, Demetria's theory ascribes an important role to hypercognitive processes of self-recording, self-monitoring, and self-regulation, and it recognizes the operation of several relatively autonomous domains of thought. Demetria, 1998. Demetria, Maui, Spinaudes, 2010. Piaget's theory stops at the formal operational stage, but other researchers have observed the thinking of adults is more nuanced than formal operational thought. This stage has been named postformal thought. Postformal stages have been proposed. Kurt Fischer suggested 2, and Michael Commons presented evidence for 4 postformal stages: systematic, metasystematic, paradigmatic, and cross-paradigmatic. Commons and Richards, 2003. Oliver, 2004. There are many scholars, however, who have criticized postformal thinking, because the concept lacks both theoretical and empirical verification. The term integrative thinking has been suggested for use instead. A sentential stage, said to occur before the early pre-operational stage, has been proposed by Fisher, Biggs, Commons, and Richards. Searching for a microphysiological basis for human mental capacity, Trail, 1978, Section C 5.4. 1999, Section 8.4 proposed that there may be pre-sensorimotor stages, M. 1L, M. 2L, which are developed in the womb and or transmitted genetically. Jerome Bruner has expressed views on cognitive development. Michael Lamport Commons proposed the model of hierarchical complexity. Kyron Egan has proposed stages of understanding. Lawrence Kohlberg developed stages of moral development. Andreas Demetria has expressed Neo-Piagetian theories of cognitive development. Lou Evinger's stages of ego development. Ken Wilber has incorporated Piaget's theory in his multidisciplinary field of integral theory. The process of initiation is a modification of Piaget's theory integrating Abraham Maslow's concept of self-actualization.